Hello everyone, in this video we will discuss the sawtooth wave. As you see, the graph of this function looks like a tooth of a saw, so they call it the sawtooth wave. I have to say that only the eyes of the mathematicians look very deep into the straight line and prove that the straight line is formed by the sum of all the sinusoids. So let's take a look at that on the next page, where I illustrate to everyone how this sawtooth wave is the sum of all of that sine curve, or the sum of all the sinusoids. Okay, so take a look at this. I only have one term in this case. Fx is equal to negative sine x divided by pi. So in this case, I only have one side curve like this. So the behavior from, I would like you to take a look at from 0 to 10. Okay, 0 to 10. See how it goes. Okay, so it's going sideways, repeat itself from 0 to 10. Okay, so that's 1. Now I add another terms. In this case, I'm adding that with negative sine of 2x over pi. So still within the period from 0 to 10. You see the shape of this one changing to this. Okay. Alright. Okay, so this is 2. Now go to the next one. I'm adding 5 terms in this case. You see how it started to change? But I still go within the 0 and the 10. Okay, so this is the 5 terms. So let's repeat this. Here I only have 1. Okay, so 1 term is a sine graph for sure. In this case, I add another negative sine 2x over pi. It turns into this. Now I have 5 terms, it turned into this. I got 14 terms, I got 26 terms. Now you can see that it almost turned into like a straight line, right? So here I have 50 terms. So in this case, I will have a sawtooth wave. Okay. So let's work with this example. In this sawtooth wave, I have to find the Fourier series. But to find the Fourier series for this is pretty simple because it's already given for me as fx equal to. Okay, so in this case, it's giving me fx equal to this formulas. So I just have to write the Fourier series with 7 terms. Okay, so I'm going to write it on the next page. So it asks for 7 terms. Okay, so let's write the equation down. So the equation asks me to do this. Fx is equal to 2 divided by pi. Alright, okay. And I have to get the summation from n equal to 1 to infinity. But in this case, I only need 7 terms, so I will write 7. So that means I will work with n from 1 to 7. And the equation gave me as minus 1 to the exponent n minus 1 times 1 over n times sine of nx as the argument. Okay, so that means I will have to have n equal to 1, n equal to 2, n equal to 3, n equal to 4, n equal to 5, n equal to 6, and n equal to 7. So 7 terms in this case. So when n equal to 1, I should have this. I should have 2 over pi multiplied by minus 1 to 1 minus 1 over 1 sine of 1x. Okay, so let's write in a different color so everyone will recognize that I will have n minus 1, so it's, in this case, 1 minus 1, 1 divided by 1, and sine of 1x. So let's see what we have. Okay, so minus 1 to the exponent 0, it will be equal to 1. Okay, so I will have 2 over pi. So this will be 1. 1 times 1 is 1. So I should have 2 over pi times sine of x. Okay, so given n equal to 1. Now, when n equal to 2, okay, so let's see, when n equal to 2, I should have 2 over pi, 2 over pi, and I will take minus 1 raised to the exponent of 2 minus 1 and multiply by 1 over 2 and sine of 2x. Okay, so let's highlight this. N equal to 2. So that means 2 minus 1, 1 over n, 1 over 2, and sine of 2x. So in this case, I should have it equal to 2 over pi. Okay, minus 1 to the exponent 1 would be still minus 1. Okay, so then I multiply that outside, that become a negative, and I should have time that with a half sine of 2x. Okay, so let's continue with n equal to 3. Okay, so when equal to 3, I should have 2 over pi, okay, minus 1 to 3 minus 1 times 1 over 3 sine of 3x. Okay, so then what is this equal to? So 2 over pi minus 1 to the exponent 2 will give me a positive value. So in this case, it's just equal to 1. So I will just have times 1/3 of sine 3x. In this case, I should have a positive. Okay, so I write positive here because I want to emphasize to everyone later on what the minus 1 to certain exponent mean. So right here I should write negative. Here I will say positive. Okay, so now n equal to 4. So what I have will be 2 over pi minus 1 to the exponent 4 minus 1, 1 over 4 sine of 4x. Okay, so what I have will be minus 1 to the exponent 3 will be a minus, so this will be a minus 2 over pi times 1 over 4 sine of 4x. Okay, so let's highlight this negative. Okay, now when n equal to 5, I should have 2 over pi minus 1 to the exponent 5 minus 1, 1 over 5 sine of 5x. So I should have it equal to minus 1 to the exponent 4 in this case, I would have a positive values. So positive of 2 over pi times 1 over 5 sine of 5x. Okay, so we do a few so we can recognize the pattern. So when n equal to 6, then I should have 2 over pi minus 1 to the exponent 6 minus 1, 1 over 6 times sine of 6x. So in this case, you are having minus 1 raised to a negative, raised to 5, that means an odd exponent. So you should have a negative as the answer. So I will write negative. And then I will have 2 over pi times 1 over 6 sine of 6x. Okay, and let's try another value for n equal to 7. So that means I should have 2 over pi times minus 1, 7 minus 1, 1 over 7 sine of 7x. So I should have this as a positive value of 2 over pi times 1 over 7 times sine of 7x. Okay, so let's put all of this together. Okay, we are going to add all of that up because writing the Fourier series with 7 terms, I should have fx equal to, so I will write 2 over pi times sine of x, and then I subtract that with 2 over pi times 1 over 2 sine of 2x. Then I add that with 2 over pi times 1 over 3 sine of 3x. And then I subtract that with 2 over pi times 1 over 4 times sine of 4x. And I add that with 2 over pi times 1 over 5 times sine of 5x. Subtract 2 over pi times 1 over 6 sine of 6x. And then I add that with 2 over pi times 1 over 7 sine of 7x. So this is the 7 terms that they asked me to write for this particular sawtooth wave. Okay, so this is the sawtooth wave, and given the Fourier series for this would be equal to this equation, and they write it as a summation, and I have to expand it to have 7 terms, and those 7 terms that I add up is actually a function of sine. Okay, so now you see that the minus 1 in this case to the exponent n minus 1 is to tell you that it's actually alternating between the plus value and the minus value, or the positive values and the negative values. So let's get back to our Fourier series. So now you see that I can factor out the 2 over pi. Okay, factor out the 2 over pi. I should have sine x left, subtract a half of sine 2x plus 1/3 sine 3x, and then I subtract that with 1 over 4 sine of 4x plus 1 over 5 sine of 5x, subtract 1 over 6 sine of 6x, and then I add that with 1 over 7 sine of 7x. So this is the Fourier series for that waveform as a sawtooth wave, given the equation and a summation, and I just have to expand it into 7 terms. And as you notice that the minus 1 to the exponent n minus 1, given n equal to 1, 2, 3, 4, 5, 6, 7, is to let you know that you will have a negative and a positive, or the positive and the negative, the positive and the negative in this case. Alright? Okay. So, what do we want to draw out from this questions? What we want to draw out from this question is according to what we have at the very beginning of the lesson. You see that I am having this as a sawtooth wave. I can factor out, here they factor out the negative 2 over pi, so inside the bracket they have all of this value. Okay, yeah. So where we have is according to this, we are having a sawtooth wave, but this equation as fx, the sawtooth wave, but is an addition of all the sine wave that you have enough here. Alright. Okay. And the one I asked you to figure out the equation for this, the Fourier equation for this, you see that it shifts to this side of the graph. Okay, so when it shifts to this side of the graph, my Fourier series is different. It's an alternation between a plus and a negative, a plus and a negative, a plus and a negative in this case. Alright, okay. Alright, so the next part of this lesson is I want to go over the formulas on page 14 of the my workbook. Okay, so we are talking about Fourier series for periodic waveform in this case, and we have to talk about the voltage versus time. So as you see that if you write the Fourier series for voltage versus time, you don't have fx anymore, but it turns into vt, and you don't have x, but it turns into 2 pi over t. Okay, and I want to just do a quick reminder to everyone so that you know where the 2 pi over the period of t times t coming from. Okay, so let's work with that. But before I get into that, I still want to remind everyone that all the terminology is still staying the same as the constant term, the fundamentals, the second harmonics, the third harmonics, the fourth harmonics, the fifth harmonics. But in the case of x, we are having the function cosine in terms of t, and in front of that t, we are having 2 pi over t, 4 pi over t in this case, 2 pi over the period, 4 pi over the period, 6 pi over the period, 8 pi over the period, 10 pi over the period, instead of just have 6. Let's say in this case I should have 6x, or I should have 3x, then why don't I have those values, but it turned into 6 pi over t, 2 pi over t, 4 pi over t, 8 pi over t, 10 pi over t, and I want to demonstrate that for everyone, why we end up with those values. Okay, so let's go here, and before I do that, I just want to remind everyone this. Okay, what we have is right here, we have x. You see that? We have x. We have x. But we don't have that anymore. We are working with fx. But we are working with t in this case, and voltage versus time. And when voltage versus time, our fx become our vt. Okay, you see the constant terms stay the same, it's just a0, but the Fourier coefficient a1, a2, a3, or an, b1, b2, b3, or bn in this case, will actually turn into this formulas instead. Okay, alright, so turn into that formulas, and I would like to go over to why we are having this argument for cos and sine. Okay, so doing that, I would like everyone to let x equal to omega t. Okay, omega is angular velocity, and angular velocity is defined as 2 pi f. Okay, from this I want to solve a frequency. So frequency will be equal to 1 over the period. Okay, so instead of writing my f, I will write omega t as 2 pi divided by the period. Alright, okay, so I will write omega, my angular velocity, as 2 pi over the period t. So now I'm going to substitute omega into here. So now x will be equal to 2 pi over the period of t times the t. So instead of writing x, okay, I will replace that x by 2 pi over t of t. Okay, so let's do this. Okay. I will write, excuse me. It's just my throat. I just drank a bit of tea there. Okay, so let's try this. I have Vt, alright, so it's Vt, and it's defined as A naught, add that with the summation of, let's work with just 3 terms in this case, okay? So I will have n equal to 1 over 3, so but just rewrite our formula so I can show you how it actually works. I will just work with my an times cos of 2 pi n over t times t. So that is the original equation that we have for this. And then we have bn, the coefficient b for the Fourier series. Okay, so we got them all correct in this case. So now I'm going to replace the I will show you why I will have all the term turned into the 4t, the 6, the 2, the 4, and the 6. Okay, so let's work with just 3 terms. Alright, okay, so I will write n equal from 1 to 3 of an cos of 2 pi over t and t. So this is exactly what I have there. I just repeat it for you to see. Okay, so then I will write a1, okay, where n is, I will substitute the value for n equal to 1, and then n equal to 2, and n equal to 3. So when n equal to 1, I have a1 times cos of 2 pi over t times 1t. Then I add that with now a2, so n now turned into 2, I will have cos of 2 pi t times 2t. So for 3, I should have a3, right? Then cos of 2 pi over t times 3t. So what you do next is you are going to take this number and you multiply it in here. Okay, because it belongs to the argument, so you can go ahead and do that. So this is part of the argument as well. So I'm going to multiply that with that. So I will have a1 times cos of 2 pi over t. Then I will have a2 times cos of 4 pi over t. Then I will have a3 times cos of 6 pi over t. So let's compare with the formulas that I see up here. Okay, now you see why I am having this turn into 4t, that turn into 6, 4 pi, 6 pi, 2 pi, 6 pi, and 2 pi, and similar to the b coefficient, I also have sine of 2 pi and sine of 4 pi and sine of 6 pi because of the concept that we just analyzed here. Alright, okay, thank you everyone.